Alright everybody, welcome back. In this video we're going to look at the last two examples from the Integrating Vector-Valued Functions lesson. We'll start here with example 4. We're given the velocity vector of a particle moving in a plane. The first thing we're supposed to do is find the particle's position as a vector function of time, and we're given an initial condition, so this is an initial value problem. We will take the integral of the velocity function that we have, and so I'm just going to integrate component wise. This is going to be t squared j plus the natural log of the absolute value of t plus 1. Oh, I've got a typo there, that's an I. T squared I plus the natural log of the absolute value of t plus 1j plus our constant vector, and when t is equal to 1, there's our constant vector, and so we've got natural log of 2j is equal to 1i plus natural log of 2j plus our constant vector, and so our constant vector is just going to be 1i, and so our position vector will be r of t equals t squared plus 1i plus the natural log of the absolute value of t plus 1j. And there's our position vector. Part B, find the distance the particle travels from t equals 0 to t equals 2. And so really what we're looking for is we're looking for the length of this path. And in order to find the length of this path, we're going to use probably the best way to do this is to use the velocity function that we're given and use our arc length integral. So this is going to be the integral from 0 to 2 of the square root of dx dt squared plus dy dt squared with respect to t, and that's going to tell us the arc length of the position vector function, which is going to be the total distance that's traveled. And so I'm going to go ahead and integrate this with my calculator. I've got the quantity 2t quantity squared plus quantity 1 over the quantity t plus 1 quantity squared, close the square root with respect to t from 0 to 2. And we get 4.335 as the distance that the particle travels. You know what, I just glanced up at it really quickly and realized that I made an arithmetic boo-boo in part A. The constant vector should have been negative 1i, because we got to subtract that from both sides, which makes this t squared minus 1i instead of t squared plus 1i. Sorry about that. Hope you all were screaming at the video, "Oh no, Mr. Thomas, what are you doing?" Alright, let's go on to example 5. We go back to free response question number 2 from the 2012 AP Calculus 8 BC exam. We've got the same lead-in. We saw this in the derivatives of vector-valued functions lesson. First thing we want to do here, we want to find the x-coordinate of the particle's position at time t equals 4. Okay, so to get the x-coordinate of the particle's position, we're going to take, we're looking for the x-coordinate at time 4. We're going to take the known location that we have. At time t equals 2, the position is 1, so we want the position at 2. And then we're going to add the integral from 2 to 4 of dx dt with respect to t. And so the particle's position at time 4 is going to be equal to particle's position at time 4 is going to be equal to x of 2 is 1 plus the integral from 2 to 4 of dx dt. And I'm just going to go ahead and do that on my calculator. I've got 1 plus the numerical integral, because again, this is a calculator problem, and so we want to go ahead and use these numerical derivative and integral functions when we're on a calculator section, instead of trying to take the integral or derivative by hand. And we get 1.253 for the x-coordinate of the position at time 4. Alright. Find the distance traveled by the particle from time t equals 2 to time t equals 4. Again, when we have a vector-valued function like this, in order to find the distance traveled by the particle, we're going to use the arc length formula. We have already the components of the velocity function, which is what we need for the arc length formula. And so we're going to take the integral from 2 to 4 of the square root of the x component squared plus the y component squared with respect to time. And now I'm going to break out my handy-dandy calculator again. Go to Math 9. I've got the square root of, alright, let's see, quantity, square root of t plus 2, close quantity, over e to the t, close exponent, close quantity squared, plus quantity sine of t squared, close quantity squared, close the square root. Again, this is one of those times that I really wish I had that fancy newfangled calculator with the math type instead of having to kick it old school. I hope I typed everything in correctly. I tried to be really careful and really meticulous with this. And we get 0.651. Sorry about that. I don't know if you heard that. I got a phone call there. We end up with 0.651, that very loud ringing in the background. We end up with 0.651 for the total distance traveled. Alright, that's the end of this video and the end of this lesson. See you guys next time. Have a great rest of your day.